Okay, so now I will talk about next part of spherical polar coordinates. So here I will start with the plane angle and then talk about the solid angle. So first of all, let me define plane angle. So suppose uh, there is an arc and say this is radial background. When it is rotated in this way, it will make an angle theta here, and this angle is known as plane angle. So basically this angle depends upon this arc, because when this arc will becomes here, then the angle changes, and now the angle will become this one. So when arc will be this one, then angle will become this, say theta 1. So for L length of the arc, the angle is, for L length of the arc, angle is theta, but when length of the arc will become L1, length become L1, means L1 is from here to here, so this is L1, then angle will become theta 1. But the another interesting thing which is happening for this one, that this r is, this distance will remain the same, this is also r, this is also r. So that means theta depends upon length of the arc, but for a particular circle r is fixed. But if I take this r, then for different circular arc, angle depends upon that r and the length of the arc. So that means angle basically, which I am calling it as a plane angle, it depends upon the length of the arc and also on radius. So therefore this plane angle is defined as the angle can be defined as the ratio of length of the arc and radius. So mathematically what I can say, that say this is a small length dl, it's formed for a radial vector r or the radius r, and say it is the origin, then it will make an angle theta, d theta here. So therefore this d theta is equal to dl upon r, and it is measured in radian, so that means angle is said to be 1 radian if dl is equal to 1 unit and r is equal to 1 unit, or we can say that if dl is equal to r, then we can say that this d theta is basically 1 radian, or simply we can call it as a theta. So in such a situation, means when length of the arc is equal to the radius, then angle subtended at the center is angle subtended at the center of the circle is 1 radian. And another very interesting thing, when this particular radial vector completes a complete rotation or complete circle, then it subtends an angle 2 pi. So that means a circle or the circumference of circle makes an angle of 2 pi at the center. The center of circle. So that means 2 pi, because when circle completes, that means it means angle of 360 degrees. So it is in radian and it is in degrees. So we can interconvert all these things, means this 1 radian is equal to 360 degree upon 2 pi, and 1 degree is equal to 2 pi over 360 degrees. So these are the two relations which can be used to convert radian into degrees and the degrees into radian. Using this concept of angle or the plane angle, we can mathematically try to look at the solid angle. It is similar to it. So suppose we are having a sphere. It seems like a circle, but it is a sphere, and say it has, I am considering it's a small portion, and let us call this small portion as a ds, and say it is the center. So if it is connected through this one, if it is connected in this way, then it is r. So in case of solid angle, we are considering a length over the circumference of circle, and it is r. So length over radius gives us the length of the arc over radius gives us the plane angle. So here in the similar fashion, we can consider the ds is a small area element, and every point over this, if it is connected through this, what we call connected through the center and its radial distance, and every point is equally distant from, means if this whole of the region which I am considering over it, then this is r, this is r, this is r. So every distance is equally distant. So then if I take it square, then this will define for us angle in the, not in a plane but in a space. So we call it as a solid angle. So it is similar fashion as we have seen for this circle, but it was little different. Here we are talking about the ratio of lengths, but here we are talking about the ratio of areas, right? So let us define it in terms of words. So what is it? Solid angle subtended by a surface surface at a point is measured by by ratio of the normal component of the area of the surface to the square of the distance of surface from that point, from that point. So it is surface, solid angle subtended by a surface at a point is the ratio of normal component of area of the surface, means here it is a normal component, so means it is like this. It is a normal component because area is a vector quantity, so we are considering it as its vector normal component, right? To the square of the distance means if I want to interested to find out the area at this point, solid angle at this point, then what I will do, I will take its distance from that surface from this point, right? So that's what we have defined it here. So let us try to look at this, how we take care this normal component here. So suppose it is some area element is like this. This is the area element, and say this is a point. So if I draw this point from this, right, if I draw this point, so that means its radial vector is this one, so it is the r vector, so it is r cap, and say it is a r vector. And now area is along this direction, so normal component of this is along this way. Its normal component is this way. Say its normal component is this way. Sorry. So say this is it. So its normal component is this way. Say r is this way, and for this particular situation, the normal is this one. So both are making an angle theta. Say because for this particular area dA, its normal component is this way, and radial vector is posed along this direction. So both are making an angle theta. So if we are making an angle theta, so that means I am interested to find out the component of this area along r cap, or the area element along r cap. So then that can be written as like this, say d omega, say it is making an angle d omega at this point. This is known as a solid angle, and this solid angle is basically dA cos of theta. Rather than theta, let me call it as alpha, because it should be little bit different from earlier one. So it is alpha and it is alpha. So it is dA cos of alpha divided by r square. So we can write down it as the dA dot r cap divided by r square. So this is a way that how we can define a solid angle. So it is a normal component, right? So let me now define its units. So solid angle is as can be defined as in terms of another unit that is known as T radian. So as we know that d omega is equal to dA over r square, So that means if DA is equal to R square, if DA is equal to R square, so let me do one thing. Say it is we are having a say some surface, or we are having a some closed surface like this, and say I want to find out the solid angle at this point, and if I take say these two distances like this, just a minute, yeah. So I will do one thing, yeah, this is one thing and this is R. So if I am considering area over this element, then this can be represented like this. So it is R, it is R, it is R, and then this area which I am considered, it is in the form of a say square, so it is R square, it is the area of this, and this is the radial distance. So that means in this case dA is equal to R square. Means if I cut a square over a surface, closed surface, which is equal to R square, then that area basically subtends an angle equal to 1 steradian, right? So this is a way that how 1 steradian can be defined. So then d omega can be said to be 1 steradian. So therefore let us define it. So 1 steradian is defined as a solid angle subtended at the center of a sphere, by a surface area equal to square of radius of sphere, right? So that's all for this solid angle and the plane angle. In the next lecture I will talk about certain properties of the solid angle.